Am I on? There we are. Good morning, everyone. Welcome. This is the Hyper-V Cloud Fast Track session. My name is Brian Sarasi. I'm a senior program manager on the Windows Hyper-V team. I've been with Microsoft for about a decade now. I started with infrastructure design, and about 6-7 years ago, I moved over to the virtualization team right when Microsoft was getting into the game. We started obviously with the virtual PC and the virtual server product. And then moved quickly into the Hyper-V technology. And I also, along with a peer of mine, a gentleman by the name of Arno Meme, I run the engineering aspects for the Hyper-V Cloud Fast Track program, which is what we're here to talk about today. So our agenda is as follows. We're going to spend a little bit of time with a general cloud overview, talk about what cloud is, how Microsoft views cloud, both public, then of course private cloud. We're going to talk about some of the benefits of a traditional private cloud infrastructure, and then we're going to get into what Hyper-V Cloud Fast Track really is. We're going to look at the architectural principles, some of the decisions we made when we came up with our design, where these principles came from, and then we're going to end the session looking at some of the various OEM solutions and partner solutions. So as you likely know, Hyper-V Cloud Fast Track, the program, is really a conglomeration or a collaboration, moreover, between Microsoft and our partners to create and deliver a joint infrastructure. It's not just the software, it's not just the hardware, it's the full infrastructure, end-to-end, built together and built as a package. So let's take a look at the evolution of computing. This is looking back a little bit. Obviously, a decade ago plus, we had what we call traditional computing. We saw traditional data centers growing rapidly. There was a great deal of server sprawl. We saw individuals, this is before the days of virtualization, we saw individual servers being purchased. One workload typically per server. There was some technology out there designed to do kind of resource consolidation or resource dividing up to run multiple workloads on a single server. But that was really kind of the rarity. So usually we saw one server per workload, and traditionally these servers were drastically underutilized. Typically, we saw servers being utilized less than 10% of the resources, sometimes more. But when you looked across a given infrastructure, you might see, hundreds, if not thousands of servers, all consuming a tremendous amount of space, tremendous amount of power, very low utilization. Starting approximately 10 years ago or so, we saw traditional, what we now see as traditional x86 virtualization come into market and become mainstream. Of course, this is Hyper-V technology, this is VMware technology, this is Xen technology, where now, for the first time, we can actually isolate a workload in an operating system inside of a virtual machine and consolidate these virtual machines on fewer instances of hardware. We obviously saw lab utilization go up significantly, lab space went down, power consumption, cooling costs went down dramatically, utilization of servers went up significantly. Instead of these 5% utilizations, we're now seeing 70% utilization of your servers, 80% utilization of your servers. And the way Microsoft views it as cloud is the next logical step or the next evolution of this. Cloud traditionally will take a hold and leverage these virtualization concepts, but also extend upon them, make them elastic. From a user perspective, the cloud is infinite resources. The cloud is a single resource pool. Me as an application developer, I basically can create my application and I can deploy it onto the cloud and know that this infrastructure will dynamically take care of it, that there are available resources, that it will allow it to scale. It will allow it to migrate throughout the servers in the cloud based on resource utilization, based on best match of resource utilization. So this elasticity, this design scalability, these are some of the key attributes that we view in a cloud infrastructure and some of the key attributes that we enable with Microsoft Hyper-V Cloud Fast Track solutions. Now, we have two different types of clouds, so we're kind of just setting the stage here from a semantic perspective. The first is what we have is a public cloud, and then the second is what we refer to as a private cloud. The key distinction here is basically the distinct workloads that are running on the infrastructure. A private cloud and a public cloud can inherently look very similar, but the difference is, in a traditional private cloud, it's not just my resources. It could be resources from other companies. My server, my workload could be running on this processor at this time. 5 minutes later, even 5 seconds later, that processor can be used for another workload by a completely different company. With a traditional public cloud, I give my resources to the cloud. I don't know exactly where they're running, what infrastructure, what components. I don't run, I don't manage, I don't own this infrastructure. Now, in a private cloud, same concepts with elasticity, same concepts with scale, but in this case, it's mine. I've still deployed these same concepts. The infrastructure is very similar in design, but it's my infrastructure. I might have multiple business units within my company running across this cloud, but it's still my cloud. Now, there are 2 different kinds of private cloud, just to add a little complexity. You can have a hosted cloud. So it doesn't necessarily mean that this cloud is on site, but you can actually have hosting companies, for example, host private cloud. They will build up an infrastructure, or they'll carve out an existing amount of infrastructure specifically for you. Again, the concept is there is no traditional multi-tenancy. There's not other companies or other applications that I'm not aware of running on the infrastructure. So the private cloud is that isolation of it's my infrastructure, it's my workloads. Now, when we think about how to approach private cloud, there's several different models, and all of these kind of fit under the Hyper-V Cloud banner. Looking at this chart, if you want to read it correctly, across the bottom we have deployment time. The bottom is actually kind of reversed here. High time of deployment is on the left. As you progress to the right, it goes to low time of deployment or rapid deployment. And the vertical would be the level of pre-integration. So the first way to think about it is custom. I want to build my own private cloud. I want to build it from scratch. I want some general guidance. I want some general best practices, but I want to design it and build it myself. Obviously, you have a lot of potential customization. It can be exactly the way you want it to be, but typically the deployment time is going to be high. It's going to take quite a while to develop this, to architect this, and to get this thing deployed into your infrastructure. Also, level of pre-integration directly goes with deployment time. Nothing has been pre-integrated. I need to validate how my SAN is going to work with my servers. I'm going to have to validate how my HBAs work and the capacity of my network and the network backplane and all these different aspects. There is no pre-integration. As part of my infrastructure design, I have to figure those things out. Now, on the opposite end of the spectrum, we have service providers. So this is, I'm going to go to a service provider, I'm going to buy cloud services from them. The great thing about that, as far as deployment time, it's very rapid. I haven't built anything. I haven't architected anything. I'm taking my workloads and I'm deploying it on a private cloud that's being hosted for me. A potential downfall of it could be the level of customization. It's not hosted by me, and there probably is limitations as to what I can and cannot do. And in the middle is what we refer to as reference architecture. This is somewhere in the middle where we've taken these best practices, these recommendations, all these lessons that we've learned in the field. We've already developed a reference architecture, and we've already integrated that reference architecture onto hardware, with the compute hardware, the storage hardware, and the networking hardware. It's right in the middle, and this is really where Hyper-V Cloud Fast Track plays. So taking these 3 principles, on the left, again, is this concept of build it yourself. Under the Hyper-V Cloud umbrella that we announced back in TechEd Europe in Berlin several months back, these are kind of the 3 major pillars. The first is the Hyper-V deployment guides. These are the best practices, the best recommendations that we've gathered through Microsoft MCS Field, through our partners, and through the product groups. We literally had hundreds and thousands of pages of documents, best practices, and actual implementations on site that we've brought together, and these deployment guides can be used, and they are available. This is, again, on-premise private cloud, and the content is called the Hyper-V Cloud Deployment Guides. On the other end, again, skipping all the way to the right, we have the hosted private cloud, and this is part of the Hyper-V cloud services providers. So we've worked with different hosters to take Hyper-V, to take our best practices, and to build private cloud offerings on their infrastructure and offer it to the customer. Again, this is the pre-configured, built by a hosting company that you can leverage. Still private cloud, still isolated for your customers' workloads, but hosted by a hosting company. And again, as part of this program, we've worked with these hosting providers. We have a whole list of hosting providers that have built private cloud based on our architecture, based on our guidance, and you can engage with them. Now, the middle is where we play and what we're talking about here today. This is Hyper-V Cloud Fast Track. That same set of guidance, those same best practices, that same knowledge that's been obtained from MCS, the field, and our partners and our product groups, we have built a reference architecture. It's a several hundred-page document that talks about design best practices. It talks about enabling your management infrastructure for that elasticity, for that level of scale. It talks about SAN design. It talks about network design. It talks about high availability compute design. It brings all of those components together, and not only do we have a reference architecture, but we have a program that engages with our partners, and we're going to talk about that in a minute, to actually validate and build. So we build out these architectures with our partners. We run through a whole series of validations to make sure that this architecture adheres to the Microsoft Hyper-V Cloud Fast Track principles. We build a reference architecture guide that talks about Microsoft's principles and the OEM or our partners' principles combined together. We have a build guide that talks specifically about how to build one of these things out. The beauty of this concept here is it's been proven. This isn't just reference to the point of it's theoretical. It actually has physically been built out. The integration of all the components, the management stack, the software stack, the virtualization stack has already been proven. And a build guide, which includes both clickstream guidance as well as automation scripts, has been created. Also, as part of Hyper-V Cloud Fast Track, there's an operations guide. Once you have this infrastructure deployed that's already been proven, already been tested, how do you operate it? How do I add additional hardware devices or scale my physical servers in the environment? How do I deploy virtual machines into the environment? These are operational guides or operational processes that are shown in the operationals guide. So this is Hyper-V Cloud Fast Track. It is these best designs and principles, and it's basically proven out on physical hardware in a real-world environment. So again, we kind of covered some of this, but on the left we have our prescriptive configurations. So we do talk about servers. We support both blades and traditional rack mount servers. We go into the networking switch design. We go into the storage array design. And then the Microsoft solution stack, obviously this is built on Hyper-V virtualization technology. And then in addition, we have the management stack. This includes Microsoft System Center Virtual Machine Manager, Operations Manager. There also must be a front-end portal, or basically a way to deploy virtual machines. We offer self-service portal version 2.0, which is part of basically an add-on into the System Center Virtual Machine Manager product. That is kind of our default standard. We do have partners that have chosen to basically replace that. We are fine with that. They have additional value-add technology that provides additional self-service technology. That's okay. We also have solutions that include Data Protection Manager and Service Manager as well. And then over here on the far right, these were the partners that we announced with on launch day back in Berlin at TechEd Europe. We have fast-track solutions from Dell, from HP. We have a fast-track solution existing today with IBM. In addition, Fujitsu, Hitachi, and NEC are working currently on their fast-track solution. Some of the guidance is already done. Not all of it is quite there, but as you'll see in the next slide, over the next couple months, those solutions will be complete. And then as was announced yesterday, we're very excited to also say we have our first dual partner solution that's been created. It's been fully validated. It is done. It is in market and ready to go. It is the NetApp and Cisco solution. So this is NetApp storage, this is Cisco networking, and this is Cisco servers. We are completely finished with it. It's been validated, so we have that build guide, that operations guide, and that joint reference architecture guide. And in a couple minutes, I'm going to actually bring a gentleman up on stage from NetApp, and we're going to take a look at some of their solution and take a look at some of the advanced capabilities of that fast track solution for NetApp and Cisco. So the key value propositions, number one, speed to deployment. Again, you can take the best practice guidance that we have, and you can try to build out your own infrastructure, and it's good guidance, but it's a lot of heavy lifting to be done. One of the key things that we have is the speed to deployment. We've taken a lot of guesswork out. We've already designed the infrastructure for scale, for elasticity, for speed, for performance, and for security. So we've taken a lot of the guesswork out of it, and so typically when you pick up a fast track solution and you go to deploy, it's going to be rapid. We reduce months potentially down to weeks. Now, is it anticipated that you're going to grab a fast track solution, drop it, push a button, and go? Possibly, depending on the solution, and possibly if you're going into a greenfield environment. But as we all know, it's pretty rare to do greenfield where there's no existing infrastructure. What's more likely is you'll take a fast track solution, and you will basically figure out either with the services engagement or with your own team, you'll figure out integration. You might already have some networking set up. You might already have some management components. You might already have an Active Directory infrastructure. So there might be some work to figure out how to integrate it with some of your infrastructure services. But the point is, some of these security best practices, scale best practices are already done, already figured out, and you can just implement it without having to do all the heavy lifting. Reduce risk. Again, it's been proven. This isn't just theoretical. This has actually been built. This has actually been validated. And finally, flexibility and choice. There are other private cloud solutions out there, not from Microsoft. What we typically see is they're very limited from a partner perspective. What we see, for example, is some people saying, oh, I'm interested in this other solution from this other virtualization company, but they have a very limited partner segment. They want me to go with one partner, one option. I don't have that kind of storage in my environment. For example, I have NetApp storage in my environment. I want a solution where I can continue to purchase and use NetApp. I have already knowledge base of my IT staff of how to use this. The value proposition of Fast Track is we have multiple vendor options. If you already have engagement with Dell, we have Dell solutions. If you engage with IBM, we have IBM solutions. NEC, Fujitsu, Hitachi, Cisco, NetApp. We have multiple different solutions from multiple different vendors that you can choose. So there's a key in the flexibility. Also, our architecture is open. It's fully documented. The APIs we use are going to be PowerShell. They're going to be typical WMI. They're easy to integrate with. Entire System Center Virtual Machine Manager product is built on top of PowerShell. So all of this stuff is open. So if you need to augment, if you need to integrate, it's open, it's documented, and you can do so. So there's a lot of flexibility in that regard. So just looking at some of the architectural principles, and again, we've covered some of these already. Pooled resources. The infrastructure is treated as one large pool of infrastructure or of resources. Elasticity. It can grow. You can move virtual machines from node to node. We also have design guidance. If you deploy a fast track solution that's 8-node, we have guidance to say, how do I add additional? What basically is the unit size that I need to add? So we have guidance around growth and elasticity of the physical infrastructure. Continuous availability. Basically, from the end user or the application developer's perspective, it's just continuous available. It's always there. So we have to design and plan for redundancy. There's also always redundant I/O paths. There's redundant servers. Even the management infrastructure, like we'll talk about in just a minute, is fully redundant. Predictability. I know what I'm going to get, and I know how I'm going to get it. When I'm an application owner, I want to make sure that I get the same resources, that I get the same performance level. The Fast Track solution is designed for that. Usage-based and multi-tenancy, these kind of go hand in hand. Now, some people say multi-tenancy, I thought this was a private cloud. What we're referring to as multi-tenancy is not necessarily that there's multiple companies using the same infrastructure, but instead there may be multiple business units. And those business units may have different I/O codes, and so we need to think about chargeback. We need to make sure that we're enabling that we're logging and reporting utilization and usage based on workloads, based on VM. And so these concepts are also integrated and baked into FastTrack. Secure, this is just a given. I mean, we're in the 2010s, 11s now. Security is just an absolute must. We do defense in depth. We make sure that our principles and practices for how the infrastructure is designed basically adhere to those top standards of security through defense in depth. And then self-service. And this could mean multiple different things, but the point is here, as an application owner or as a business unit owner, I need a rapid way to get my applications onto this cloud. It can't be nebulous. It can't be, I throw it somewhere and then some magical, mystical guy does something and then he sends me a report that I have to fill out a list of how many resources and how many CPUs I need, and then he racks a server, and then 3 weeks later my workload goes up. The concept of self-service is an application owner can go to the front end of the Hyper-V cloud, can basically deploy their infrastructure or deploy, their workload onto the infrastructure, and they understand what it means from a chargeback. They understand the resources that the application is using, but the whole back-end aspect of it is not of their concern. They don't necessarily know what resources are being used. They don't necessarily know where in the infrastructure their application is, but they don't need to know that, and they don't want to know that. They just know that there's a quick and rapid way of getting their workload online, and that it's secure, it's reliable, and it's always highly available. Okay, so of all the different architectural components, these are kind of the ones that we focus on in FastTrack, and the top 4 is what we're going to talk about more today. Obviously, we have our compute components. This is our traditional server components, whether they be rack or they be blade servers. We have our network components, we have our storage components, and of course we have our management stack that manages the infrastructure. There's obviously virtualization in there as well. This, of course, is going to be Hyper-V virtualization. There's automation, and this is really twofold. Number one is deployment automation. How do I get my infrastructure built? How do the servers get deployed? How do the networks get set up? And then there's automation of how do my workloads get deployed onto the infrastructure once the infrastructure is set up. Service management, and again, as we talked about, multi-tenancy and user self-service, allowing application owners a quick and rapid way to get their workloads running. So this is a little bit of an eye chart. It might be hard to see, but this is the fundamental logical architecture of Hyper-V Cloud FastTrack. On the left-hand side, we have our management. And we spend a lot of time in architecting our management components. In some private cloud solutions that we've seen, we don't see a lot of focus on high availability of the management components. And we've even heard the comment being made, so if the management stack goes down, okay, so be it. People can't run or can't deploy new workloads until it's back up and running. But the compute cluster and the compute side of the house is still working, so the workloads haven't gone down. So it's not a big deal if the management systems go down for a little while. We completely disagree with that philosophy for a number of reasons. It is critical that you always have the ability to deploy new workloads. But moreover, that management component is not only monitoring the health and the performance of your environment, but it's also, again, reporting on usage, the chargeback. If you don't have this information, you're basically running blind. We need to understand the health. We need to understand if one of the compute nodes is going down. We need to understand if one of the HBAs have failed. So we believe firmly that the management network or the management side of the house must be highly available and must be pretty much always online. So one of the first things that we've done is most of our management components, management workloads, are actually in virtual machines. And these virtual machines are on a CSV cluster, a highly available live migration cluster. And this cluster is separate from what I refer to as the compute cluster, or where the workloads get deployed. So we have a separate management cluster just running the management VMs. And number one, these VMs are highly available through live migration, but we also know that some of our System Center products aren't clusterable themselves. So instead what we do is we actually cluster the SQL database that our management components use. So Operations Manager uses SQL, Virtual Machine Manager uses SQL, and so what we've done is we have actually done not only host clustering, but guest clustering of the SQL database. So we're running a traditional SQL cluster, running multiple databases for the different management pieces of the puzzle. Now, in our regard, to do guest clustering, we basically leverage iSCSI. We pass through iSCSI into the virtual machine to do this. So the Hyper-V Cloud Fast Track infrastructure must have iSCSI to a certain extent. Does that mean I can't have Fibre Channel? Does that mean we don't have solutions with Fibre Channel? Of course not, we do. And Fibre Channel would typically be then for the compute cluster. But what we see is either both an iSCSI network for the management nodes and then a Fibre Channel for the compute nodes. So we see a mix mash of both, or sometimes we simply see an iSCSI bridge. So there's components that basically bridge the Fibre Channel into iSCSI specifically for guest clustering. And guest clustering isn't just for the management nodes, but we also want to enable guest clustering for the virtual machine workloads as well. And then over on the right-hand side, this is our resource pool, or again, what I've been referring to as our compute cluster. This is where the heavy lifting is. This is where our servers running all the workloads would be. Again, of course, we're going to enable traditional Hyper-V live migration and failover clustering on the compute nodes. We're going to get into each one of these aspects specifically, but this is where we do multipath I/O. This is where we do redundant network paths, things of this nature. Okay, so let's take a look at management. We covered some of these things. Number one, scalable infrastructure, infrastructure deployment, bare metal infrastructure deployed. So we utilize, again, when I talk about automation, there's twofold. There's automation of building the infrastructure, and then there's automation of deploying workloads onto the infrastructure. As far as building the infrastructure is concerned, we utilize the Microsoft Deployment Toolkit and the Windows Deployment Services. And then in addition, with our partners, our hardware partners from the server, network, and storage side, they integrate as well, and they have processes that add on about how do they deploy their particular hardware, how do they deploy their particular services on those hardware as well. So when you get the final reference architecture, it's both deploying the management onto the infrastructure and the infrastructure itself. Provisioning and deprovisioning. As I said, by default, we use the self-service portal version 2.0. We have the concept of small, medium, and large virtual machines. These kind of go hand in hand with the Microsoft Operations Framework and also what MCS is dubbed. So what we do is we try to basically size a traditional virtual machine from the I/O utilization, CPU utilization, and memory utilization. So when you're looking at consolidation and deployment, you can think about how many small virtual machines can fit, how many medium-sized virtual machines, and large virtual machines as well. Infrastructure monitoring, insight from the hardware layer to the software layer and in the VM. So this is key. One of the key principles of Hyper-V Cloud Fast Track is around Pro Packs and management packs and integrations from the software stack down into the hardware stack. So we're using Operations Manager to monitor the health and the performance of the infrastructure. The beautiful thing about Operations Manager is it understands the concept of a virtual machine. It understands the concept of a physical host. So it's naturally monitoring the health and the performance. But in addition, with Pro Packs, our hardware partners basically integrate as well. So now Operations Manager and Virtual Machine Manager can monitor the health and the performance of the networking infrastructure, of the underlying servers, and the underlying storage. So when it sees an HBA go out, it triggers an alert. That alert is picked up by Virtual Machine Manager, and Virtual Machine Manager knows to basically migrate virtual machines off of that host with the failed HBA. So basically, integration of maintenance is critical for us. And resource optimization, again, dynamically moving workloads to adjust bottlenecks, consolidate on fewer resources when appropriate to increase utilization. This is the dynamic moving of the workloads. This is that flexibility that the cloud provides. This is the running low utilization. Let's basically migrate virtual machines on fewer instances of hardware, and either using core parking, or in some servers, we can actually turn off the servers to save power. And then we can turn them back on and basically migrate virtual machines back onto those servers when workload and utilization goes up. So now let's take a look at the compute aspect. This is obviously the processor, the cores, the RAM, high I/O, low latency, either blade or rack. From our perspective, either blade or rack fits fine within the fast track architecture. Now, one thing that we do is we look at high quality and we require high quality servers. This is slightly different than some cloud models, including, say, for example, Azure. Azure assumes most of its workloads are basically stateless. So it doesn't necessarily care by design, and it's a good design, but by design, if the physical host goes down, the workload is stateless, we haven't lost data, and we can just restart another stateless workload on another server. So in some cloud architectures, commodity, low-end, cheap hardware is used, because if it fails, it's just thrown out and another one is brought in. In Hyper-V Cloud Fast Track, we anticipate stateful applications. We anticipate traditional applications, even SQL workloads, line of business applications, exchange workloads, where if the system goes down, it is stateful, it has memory, there's information in that virtual machine that should not be lost. In that regard, we require higher end servers with redundancy, with high availability. By default, they're gonna have redundant power, they're gonna have redundant NICs for NIC teaming, things of this nature. So we're not using low commodity servers, we're using traditional kind of full fidelity high-end servers. As far as the server itself, its own storage, either SAS or SATA is just fine. We also see boot from SAN, where there is no attached storage in the virtual machine, in the physical host itself. And then on the SAN, because we basically leverage Windows and Windows Hyper-V, we're able to take advantage of the traditional Windows driver base, which means we support Fibre Channel, we support iSCSI, we support Fibre Channel over Ethernet, and our various OEM solutions have different combinations of these technologies. We do have requirements for throughput and performance. So for Fibre Channel, for example, we require kind of dual 4 or 8 gigabit HBAs. When it comes to FCOE, again, we require 2 or more 10 gigabit basically paths out of the system. So we do have requirements for these different technologies to ensure throughput and ensure performance. Multipath I/O is a critical aspect of our architecture as well. Again, this is the redundancy. We want to make sure that the I/O is going out over multiple areas, over multiple switches. One switch goes down, you still have another path to get to your back end. Each server must use multiple NICs teamed and or virtual NICs, and redundancy, redundancy, redundancy. So a typical server, and this isn't looking at any fast track solution specifically, but a typical server will have multiple PDUs. So again, we'll have multiple, essentially power supplies in the system for redundancy. We have redundant cooling. We have redundant backplanes. So again, we want to make sure that there is no single path of failure. This is a typical system that we would see, dual socket, sometimes quad socket, second level address translation, 64 to 192 gigabytes of RAM. And just to let you know, one of our key design principles of any fast track architecture is scale. We don't necessarily say, here's your architecture, it's 4 nodes, it's this amount of memory, you're done. We talk about it's 4 nodes, it's this amount of memory. Here's what you think about when you add more memory. Here's what you think about when you add more systems. So just as an example, the new NetApp and Cisco solution is from 4 to 16 nodes. And the memory you can start with a low amount of memory per server and basically increase it. But that gives you flexibility. And the network paths and the storage paths have basically been designed to scale. So if the customer wants to start with a small system, like a 4-node system, that's great. But we have guidance and we've architected the solution to be able to go higher to 8 nodes, to 16 nodes, to add more memory, to add bigger procs, things of that nature. 2 or more 10 gig E adapters, 1 gigabyte E adapter specifically, or 1 gigabyte management NIC, 4 8 gigabyte fiber channel, 10 gigabit based on iSCSI. SAN boot. Some of our solutions, again, have no local disks. They boot directly to SAN. That is approved in the architecture, and that is a good design. Remote out-of-band management and integration, of course, with Microsoft System Center. As I mentioned, management packs and Pro packs for the hardware in a solution is required. So now switching over to networking. It's a little bit, again, hard to see, but this is our general logical architecture for our network path. It is a tiered design. As you'll hear me continuing to say this, it is redundant, multiple path, high capacity. You also must support, or the solution must support VLAN trunks. So for example, in the diagram on the left, we have two 10 gig E network cards coming out of the server. That's handling pretty much all of the different network traffic out of the server. But we need to make sure that certain traffic doesn't get starved, so basically we use VLAN trunks to do that. It's basically isolation, segregation, to ensure that no network path gets starved. We don't want to, if you're going out over one network path, though the bandwidth may be high, you need to make sure that we have reserves or we can protect certain bandwidth. And the last aspect that we're going to cover is storage. Of course, high available storage, multipath I/O support, clustering support. And so sometimes we see basically converged storage where we have multiple things going out over the same essentially I/O path. If that's the case, that is supported, but we do require QoS, or quality of service. Again, this is basically protecting and ensuring that the different network traffic and the different storage traffic is preserved, is not starved from one another. We want to make sure that there's a certain level of quality of the service provided to all the different storage and network paths. As I already mentioned, iSCSI is required specifically for guest clustering. Sometimes we see a hybrid of both fiber channel and iSCSI being used. Sometimes we see an iSCSI bridge being used to basically enable for guest clustering for both the management VMs and the workload VMs. And by default, we do have the clustered file system basically using CSV, clustered shared volumes. This enables our high availability, our failover clustering, our live migration. We do allow for replacement of CSV with other clustered file systems. It must, again, meet a minimum bar of availability and performance, but there are others out there and there are advantages. So that's really one of our key principles. We have these high standards of what the infrastructure must do, but we also know our partners, whether it be storage, networking, or compute, have their value-add technology, and it can be very excellent high-end technology. In the Hyper-V Cloud Fast Track, we have our bar, we have our requirements list, but we can be replaced, some of our components can be replaced with higher-end components from our partners to really provide a value-add solution. So we enable that. We're not always locking you down into just the Microsoft way. We enable basically the partners to really highlight and leverage their value-add technology. So this is just an example of basically some of the integration with the management pack and Pro pack. So this is integration with the management and Pro pack for the HBA, the Fiber Channel HBA. So what we have here is we have System Center Virtual Machine Manager, we have Operations Manager, and again, they communicate using Pro and using management packs. So Operations Manager is monitoring the health and the performance of your system. Operations Manager, through the use of management packs and Pro packs, is understanding the health and the performance not only of Windows, not only of the host and the guest, but also of the hardware. So in this model, basically we have a failure either in an HBA or somewhere along the HBA traffic. That is picked up and alerted by Operations Manager, which is picked up by Virtual Machine Manager, which automatically triggers migration off of that host with the failed HBA over to the other virtual machines. If it can do it gracefully with live migration, no service interruption, it can. If the host just completely disappears, we use failover clustering and just automatically failover and restart the virtual machines on the next host. So now I want to talk a little bit about some of the configurations. As I mentioned, one of the key value props is we have partnered with all of the major hardware vendors, and more are coming, and we have multiple different solutions. This is the overview of the various solutions we have from our partners. At the top, and as I mentioned, we have NetApp Cisco solution, which was just announced yesterday. We're going to take a look at that a little bit deeper in just a minute. There again, they have a solution that scales from 4 nodes to 16 nodes. It is based on Blade. It is in market today, and you can engage with both Microsoft and NetApp Cisco for this solution. We have a Dell configuration. They were one of our original partners in the program. They built some great configurations to scale from 4 to 10. It is rack mount servers. And again, it is in market and available today. HP, and we're going to take a look at their design as well as Dell's in just a minute, but HP also has a solution. It is based on their Matrix technology as well. If you actually want to see this working today, it's here at TechEd, and I'll talk about that in just a minute. And then the IBM solution is also available today. Rack mount servers 4 to 8. They've done some especially great work with the management packs and the integration. So they're doing a great job in basically monitoring the health and performance of all their systems. And currently, we already have the reference architectures for Fujitsu, Hitachi, and NEC, and we're working on the finalization of the deployment guides and the operations guides. And over the course of the next couple months, those solutions will be fully available as well. So just briefly, we only have about a couple minutes here talking about some of the solutions. What I do highly encourage you to do, though, is go to Microsoft.com/private cloud. The different solutions, including the reference architectures, so this is the joint architecture, the Microsoft Plus, for example, the Dell components, are going up online that site. You'll see several of the solutions up there. More are still coming. But we'll just kind of talk just briefly about some of these. This is the Dell solution. They have basically integrated with their Viz self-service creator for automation of deployment and self-servicing. They're using their PowerEdge servers, specifically designed for multi-tenancies. So again, disparate workloads running on the same systems from the same company. Maximum I/O capacity. Down here at the bottom, it's a little hard to read, but it talks about some of the specific hardware advantages of the Dell technology, including the Dell EqualLogic storage technology, Dell PowerConnect, and again, fully integrated with the System Center product suite through management packs and Pro Packs. We have the IBM solution. Again, they're using their X series servers. Again, full integration with Pro Packs. They're also using the IBM storage, system storage, thin provisioning, deduplication, compression is some of the key areas of focus in this solution as well. They're using Brocade switches, 10 gig E, top of rack, extremely low latency switches. The IBM solution, again, a little more detail in this slide. These slides are available online, and this deck will also be available to all participants. So if you want to dig a little bit deeper, you can. Again, resiliency, I'm just pulling out a couple interesting points. Resiliency through integrated 6 gigabits per second RAID adapters on the systems. Comprehensive 10 gig Ethernet fabric throughout. This is just a basically graphical depiction of the IBM topology. You can see the different networking paths. We have the storage network running 10 gig E. We have the cluster public VM network running 10 gig E. We have a private cluster network. That's the heartbeat and things of that nature. 1 gig E in the management network, yes. Dedicated management to make sure the management network is never starved. Those are 1 gig E network path for the management network as well. And these are the X3650s from IBM. And then the other one that I want to talk about briefly is the HP system. So this is HP built on the BL460 blades, dual socket, 24 logical processors, They support up to 192 gigabytes of RAM, 10 gig E, 8 gig fiber channel. It's also integrated with the Dell Matrix management solution. So basically we have some Dell management integrated with the System Center, or excuse me, Dell. We have the HP management integrated with the System Center products as well. And one interesting point here is this solution is actually here at TechEd. It can be viewed if you've not seen it. It's in what they're calling the aquarium. This system, which is called the the HP Cloud Foundation for Hyper-V, is a fast-track approved implementation, and it is what is running all of the lab environments here at TechEd. It was also used at MMS just a couple months ago. Here's again some of the specs of the system. You can go downstairs and see it. And what's really interesting is here's also some of the specs. Now these are the specs from MMS. It was used a year ago at MMS, and then 1 year later, which was just a couple months ago, it was used again. Now it was implemented the second time using dynamic memory, but here's some very interesting statistics. It provisioned over 40,000 virtual machines over the course of the Microsoft Management Summit, or MMS. 530 virtual machines was the highest it hit per minute. 530 VMs deployed per minute, only 17 square feet of lab floor space, and because of the technology such as dynamic memory, they were able to do higher consolidation numbers. Between 2010 and 2011, they reduced the number of servers by 21%. Cost reduction of the entire infrastructure went down by $80,000, and 1 terabyte of memory, which was a good portion of the $80,000, was saved using dynamic memory as well. And this is an interesting mosaic that they've done. This is basically taking a look into every single one of the virtual machines running in a lab environment at the same time. Now, what I'm really excited to talk about, and in just a second, I'm going to bring up Alex Josh to talk a little bit more about it, but this is our new solution from NetApp and Cisco. It is our latest solution. It is a very good solution, and they've done a phenomenal job with automation. They've done a phenomenal job with integration with System Center, and they've done a phenomenal job with provisioning of virtual machines. This is basically the overview of the system. We're using Cisco network switches. We're using NetApp fast storage system. We're using Cisco UCS B-Series blade servers. It is our first solution that basically is joint between 2 different partners, both NetApp and Cisco. We've worked with them closely over the last 6 months to basically design the infrastructure based on fast-track principles and to validate, actually build it out. They built it out in Bellevue, which is right next door to our Microsoft campus in Redmond. And so we were on site validating the solution with them as well. As you can see, they included a number of the Microsoft System Center products, including System Center Virtual Machine Manager, Operations Manager, Service Manager, and also one of our first solutions to fully integrate with Opalis. So what we're going to see here in a minute is a lot of the automation and deployment of workloads is using Opalis work streams. And again, we'll see that in just a minute with the demo as well. So at this point, I'd like to bring up Alex Josh. He is an architect with NetApp and one of the key design guys that we worked with for the solution. So thank you, Alex.
Thanks very much.
And I'm going to hover right behind you.
All right. Hello, everybody. Hope you're having a good show. So what we thought we'd do is talk a little bit about the solution and how it works. So for those of you that are data center gearhead guys, there's the obligatory network diagram. So basically what we've got is we've got the default configuration is actually 2 UCS chassis, which can take up to 8 blades each. The default configuration is provisioned with 8 blades total, so that you have space to go up to 16. Obviously, you can customize this up or down depending on what you want. The storage component is optimized for a maximum of 16 blades. So that's why it's built that way. So you have room for 16 blades, you have storage for 16 blades, but you only get 8, and then you can grow from there. Working with Cisco is a lot of fun. They have a very good product here. Actually, especially in the areas of automation. The UCS chassis actually turns out to be one of the easier chassis to automate. They have a PowerShell toolkit that they built. We have a PowerShell toolkit we built. It was relatively easy for us to collaborate on this. You'll also notice that we're running 10 gig E. There is some fiber in there as well. This is all about customer choice. So if you're actually implementing one of these systems, what's going to happen is our engineers are going to work with you to see if there are areas of the design that need to be customized. So as Brian said, we really look at this as a design template, as a starting place. If you implement exactly what's in the guide, obviously it's just going to work and you're going to be able to follow the steps one by one. If you need to customize a little bit, that's absolutely fine. It's just a little bit more work to make sure that all your custom pieces are integrated as well. This is what we kind of refer to as the layer cake. So when we think about private clouds, and I think Microsoft and NetApp are very well aligned here, private clouds is fundamentally, the secret sauce in private clouds is about the management stack. When you look under the covers about what's really going on, once you get down to around the hypervisor level, it's virtualization, which we've been doing for some time. There's nothing really new there. The difference is that the business model and the architectural paradigm is fundamentally different. There are assumptions in cloud architectures. For example, we assume that these workloads are largely uncharacterized, right? If you were deploying Exchange on NetApp without any sort of cloud involved, we would ask you a lot of very specific questions. How many users? How big are the mailboxes? How many mail messages per day? How big are those mail messages? All those kinds of questions. And then when we'd say, OK, you need exactly 34 spindles to run your Exchange system. In a cloud scenario, A, we don't do that, and B, we cannot do that. The whole point is we don't know necessarily what's going to be there. So what that means is that the management system needs to be much more robust to allow for that. So everything from automated provisioning and automated management using Opalis through Operations Manager down into the PowerShell toolkit and all the way down into the base layers, Windows and all those kinds of things that you normally expect become so much more critical in a cloud architecture. So one piece of advice that I would give is if you are considering deploying cloud-style architectures in your infrastructure, focus on the management aspects. That's what's different. Getting that right will make your life a lot easier. So what we're going to talk about next is rapid provisioning. It turns out that provisioning and deprovisioning VMs is one of the more common operations in a cloud. It's one of the things you see. So for example, if you go to Azure, one of the things that's unique about Azure is you give them a credit card and you get VMs right away. You don't have to wait. It just happens. It appears to be infinite. It happens almost immediately. So we tend to talk about provisioning because A, it's a very complicated workflow to automate correctly, and B, it turns out it's probably one of the first scenarios that you're going to want to implement on site when you do this yourself. From our perspective, we have this new feature that we call sublun cloning, which allows us to clone a single file inside a running CSV. And that is a unique characteristic of our solution. Everybody else is usually cloning LUNs, or they're doing copy-based deployments. And if you're using very large VHD files, this can take quite a while, right? Microsoft recommends running fixed-size VHDs for performance reasons and other reasons. And in fact, all the fast-track reference architectures refer to fixed VHDs. And so being able to clone the files becomes really, really important. We also are running SandBoot on our solution, which means that the actual hard drives for the blades themselves can also be cloned and pre-provisioned. So we have pre-built, sys-prepped boot LUNs sitting in the filer. And when you want to deploy a new blade, all you do is you clone that LUN, present it to the blade, and boot the blade. It's a much simpler deployment experience than the traditional one. So we're going to see this in just a second. Let's see. I think I'm on D. Oh, thank you, sir. And I'm going to show this to you actually in a video because we have very limited time. But if you'd like to come down to the booth, all of this is live. This is all real. So what you see here is a Opalis work session. So Opalis is Microsoft's orchestration platform. And what it allows you to do is it allows you to build workflows by joining various disparate components together. Now, in this particular case, this workflow was actually designed with Cisco. And it uses Cisco's PowerShell toolkit. And what we do is we're going to provision a new blade into the cluster. And the way we're going to do this, though, is we're going to do this via the change management system. So what we see here is System Center Service Manager. This is Microsoft's ticketing system. And we're going to issue a ticket to say we want to add additional blade capacity to the cluster because we're low on capacity, right? So this would be done either in a self-service mode by a departmental administrator or probably more likely by the help desk staff. And then it would go into change management. If you think about it, in a large environment, as you scale up, change control becomes very, very critical to your implementation. So you want to have every change in the data center under change control. But normally what that means is people have to write notes and they have to write everything down. And it's kind of cumbersome. This way, the actual workflow, the actual deployment process itself begins with the change control. And in fact, requesting the change control event causes the deployment to occur. And now we see a custom form here where we specify information. Oh, sorry, it doesn't show up very good on the screen. Apologies, a little screw up on the screen there. But basically what we're doing is we're saying what kind of server we want, where do we want it, right? How much disk do we want? And this information then triggers Opalis to go out and run the entire deployment process. Now, naturally, you still need a guy in the data center to shove the blade into the chassis, of course. But other than that, everything is automated and remoted. So,
No, please.
so Opalis is basically waiting for that change control event to happen. And what we're seeing here is we're going to have dual screen here. We have the Cisco management console on one side, and we have Opalis on the other. And now we see that Opalis has picked up this change control request. And in a few seconds, what you're going to see is the Cisco administration console is going to represent the fact that we're creating a new template. In the Cisco UCS universe, the blades themselves actually have very little personality on their own. What they do is they inherit that personality from the fabric. So when you create a template, you can actually give it information like how many NICs does it have, HBAs, worldwide names, all that kind of stuff. That's nice because if you need to pop a dead blade out and put it back in, it re-inherits that personality. But at provision time, we can do exactly the same thing. And so what we're doing is we're going to fast forward a little bit. So this is why we're doing it on video, because we're compressing this. So this doesn't actually boot Windows in 30 seconds like I do here. So Windows boot time still takes a couple minutes. So we're going to speed this up a little bit. And what we're seeing now is the blade is coming up. But what's happened is that we're actually booting from a sysprep LUN. And before we presented the sysprep LUN, what we did is we mounted it locally, and we actually edited the customization file sitting in the sysprep LUN. So it comes up with the correct machine name and joins the domain and all that kind of stuff. So we clone the LUN, we mount it locally, we edit the customization file, we then dismount it, we present it to the blade as a bootable LUN, and then we boot the blade. Now, mind you, all of this has happened completely automated, right, in an Opalis workflow. If I was running this live, I wouldn't be touching the keyboard, even though I'm not here. So now what we're seeing is your standard Windows setup experience, right? This is just like any other sysprep machine that comes up. Now setup is installing and all that kind of stuff. So all those normal Windows things are going to happen. And now we have basically a clean Windows install from a sysprep image. Now we're going to skip ahead a little bit, because otherwise we'd be sitting here watching the setup bar go through. But I'm sure hopefully all of you have installed Windows before, so you don't have to watch this. It turns out that it's much simpler to deploy this type of setup, and it's more consistent. So we've skipped ahead now, and so now you see the blade is actually a member of the cluster. And you'll see that we have 4 nodes in this cluster, and that's our standard default implementation. So our recommendation is that our consumption unit in this solution is actually units of 4. So if you need 8 servers, you have 4 4-node clusters. You have 2 4-node clusters. You have 16, you have 4 2-node clusters. So what we're going to do now, so now that we're joined to the cluster, now we can start provisioning VMs against that. And surprise, surprise, that's also an Opalis experience. It's exactly the same. You could use SSP. And again, we're going to clone. But you notice what we're doing here is we're cloning a single file inside a running CSV, right? We didn't present any new storage. We have a master sysprepped VHD. We clone that VHD, which takes about 30 seconds. Then we call SCVMM and say, OK, SCVMM, you can create a VM now. But you know all that copy VM stuff that you usually do? Yeah, don't do that. Just use the VM that we already have. And what you see here is that the 1.2 step in this workflow, which normally can take 45 minutes to an hour if you're working with a very large VHD, in this case it's 133 gig VHD, that step basically took no time. And the reason is because we told SCVMM, hey, don't bother doing that. We've already cloned the file, and here it is in the CSV. And now, surprise, surprise, we see the Windows setup screen, exactly the same experience.
So this is kind of a good example of what I was talking about earlier, is we have these design principles of Fast Track, but we also, with our partners, have some really advanced technology that we want to enable and include. So to the point, I just want to make sure, I'm going to kind of reiterate what you just saw. We're using System Center to deploy the virtual machine, but the copy or cloning of the virtual machine isn't done by System Center. Basically, NetApp is integrated through Opalis to use the rapid cloning technology on the storage subsystem to do it much quicker. So this is, again, meeting the design principles, but meeting it in a way to do it really, really well using the NetApp technology.
So that was a video, which is OK, but maybe we should show something live?
Yes.
All right. So what I have here is I'm VPN'd in back home to my lab, and we have a different Opalis workflow. So one of the things that we just discussed with Brian is that high availability is really nice, and it's fantastic. But what happens when the entire data center goes away, right? What if you have a smoking hole in the ground? Then what? So from a NetApp perspective, our answer to that is automated disaster recovery. And I'm actually going to just start this workflow up and then explain it, just in the interest of time, so just bear with me. So what we have is this Opalis workflow. And what we're doing is we're simulating a planned failover event from the Seattle data center to the Tacoma data center. And we have a series of VMs that are running in Seattle right now that are under protection. Now, under the covers, what's happening is the two SAN instances in Seattle and Tacoma have a replication relationship. We call that feature SnapMirror. They're replicating on a regular scheduled basis, right? So you can be scheduled every 15 minutes, or you can be semi-synchronous, or you can be fully synchronous, depending on your network. This is an IP-level transaction. The two SANs are talking to each other all the time. In a scheduled failover event, what you want to do is you want to bring the VMs down gracefully. You want to push those last few write bits across the WAN, and then you want to bring the other side up. Now, of course, if this was an actual emergency, the first 5 steps, we just skip that, right? Because there's no need to bring them down. They're already down. Mother Nature has solved that problem for us. We aren't going to push those last 5 bits because we lost the original SAN. So we're showing it this way because this is the most complex workflow that you can actually have in a DR scenario. It turns out that testing DR is actually harder than implementing DR because you have to take care of the primary site first, then you have to actually do your DR, and then you have to bring it back, right? So it's much more complicated. So now what's happened is the machines in our Seattle side have been shut down gracefully, and we are pushing our bits across. And what happens is that underneath the covers, we're running what we call an update mirror command. What that's doing is it's telling site A, flush your queue with site B, and let me know when that happens. And it's an asynchronous operation. So actually, one of the cool things about Opalis is Opalis is a stateful workflow manager. So what I told Opalis is, don't proceed to the next step until that replication step is complete. So you see it checking, checking, checking. Now it's complete. And what we do now is we quiesce the mirror, and then we break the mirror. Only when the mirror between the two sites is broken will the SAN on the far side allow us to mount these LUNs in a read-write mode. Right? Otherwise, they're read-only. As you can imagine, replication to a mounted Windows LUN, I think the technical term for that is bad. Right? That would be bad. So we don't allow that. So once the mirror is broken, now the SAN says, oh, great, you can mount those disks on the foreign side. And so what we're doing is we're going to Windows and saying, OK, Windows, you have a new disk. And once we get a WMI confirmation that that event actually occurs, so now we query WMI and say, hey, do you have your disk yet? No, not yet. OK, let us know. Now we actually have it. So now we know Windows has the new LUN, and then that LUN is mounted read-write. Now we can actually start the VMs. Right? And now we see on the far side, we have those exact same 3 VMs, but they're in Tacoma now. So basically what I did in the last, what was that, 2 minutes 30, is I moved a workload from Seattle to Tacoma. Now, of course, I cheated, right? Because replication was already going, so I didn't have to move a lot of bits. Also, I only moved three VMs. It could have been 30. It's exactly the same process, right? And also, in this particular case, it's in my lab, right? So they're sitting next to each other. But because we're just moving deltas, and because we're just moving the deduplicated thin provision volumes, the only thing that gets pushed across your WAN is actually the deltas being written. So the amount of data you're pushing across the WAN is relatively low. So in the United States, most of our customers are running these on MPLS circuits, right, that have good bandwidth. So this is a very viable option. There's other choices you can make around, spread clusters, and but that has a lot tighter restrictions on the network. You have to have dark fiber and stuff like that. So anyway, so that's the demo, and I know we're really short of time, Brian, but that's kind of what we came prepared to talk about today.
Great, thanks, Alex. Really appreciate it.
All right, thank you, sir.
So thank you. So I do encourage you. They actually have this this technology and some of these demos in their booth downstairs. So if you want to go take a look, go down there and talk to them. The Opalis workflow scripts that he used in this are part of the Fast Track solution, are included with the Fast Track solution. And again, they're Opalis, so they can be augmented and changed as necessary to fit the infrastructure. And again, I just want to reiterate this last piece that we saw. What we have here is 2 identical Fast Track solutions, one in Seattle, one in Tacoma doing replication. So again, in this architecture specifically, we're able to do DR scenario by basically standing up 2 of the same infrastructure in separate locations. So it's really good stuff. Okay, so we're doing okay. We're kind of going into our question and answer period now. Let me just double check the time. We have a few more minutes. So what I'm going to switch over, and we have one more demo to do. disaster recovery. I want to talk a little bit about, oops, I went too far. Here we are. How many people here are familiar with the solution accelerator called Microsoft Assessment and Planning Toolkit? All right, several hands. So several very large, big hands. So this is a great toolkit. So this is out of the Solution Accelerator team. Actually, prior to coming to the Hyper-V team, I was on this team, so they're near and dear to my heart. And they make a lot of great guidance to basically accelerate deployments. And what this toolkit is designed to do is it performs discovery, assessment, and readiness analysis. Now, it's several iterations, and what we're looking at right now is the pre-release version, this is even pre-beta version, of the 6.0 of MAP Toolkit. Now, this toolkit does many different things. If we take a look here, it does Windows 7 readiness assessment. It does Office 2010 assessment. It does web application disaster recovery, Office 365 readiness. And what's really great, in the new version 6.0, basically it does consolidation planning of fast-track solutions. So let's actually switch over and take a look at that, and I'll explain it a little more in detail. So here we go, move over to C. So I actually have the toolkit right now running in a virtual machine. Why? Because I run everything in a virtual machine. And what we have is the main page. Again, you can see we have client, we have virtualization, and if we come down to performance and consolidation, we have a new click or a new link here called Hyper-V Cloud Fast Track Wizard. Now what this tool does is it's kind of two-part. It's assessing and then it's planning. The first part is it actually has components that go out and assess your workloads in your environment over a fixed period of time that you designate. Typically, it's in the order of days or weeks. So it's discovering your workloads, it's discovering the utilization trends of them, it's discovering everything that's happening in your environment, the peaks of utilization, the valleys of utilization, and it's doing it without any management agents running inside of the virtual machines. So now if I walk through this wizard, these are just a couple sample configurations. These are generic configurations of Fast Track, but I can go ahead and select one of these, and let's just take a look. Oops, wrong mouse. Let's take a look at what one of these looks like. So for the first time ever, MAP understands the concept of an infrastructure. Previous, if you've used MAP, we've done server consolidation, where it looks across your infrastructure and it tells you, okay, you got 400 workloads, and you can consolidate them in virtual machines, and you tell it, this is my server, this is how much memory my server has, this is how much disk my server has, and what it tells you is I can consolidate 23 virtual machines on one of your servers, and you need, for example, 14 servers. Well, that's fine, but that's very kind of blocky, modular, just from a server perspective. Now MAP understands the concept of an infrastructure, and specifically fast-track infrastructures. So here we can see in our infrastructure, we have what we consider a base configuration. So as I talked about earlier, our fast-track infrastructure scale from small to large. So our base configuration is 8 nodes. Our IOPS of the infrastructure is 19,000. Our SAN starts at 43 terabytes. We talk about the processors of the physical hosts, talk about the memory, talk about the disk. Now you can see disks are blank here because this field is disk on the physical servers. And this solution specifically is using boot from SAN, so there are no physical disks on the servers, so this is blank. And then network, you can see we're using 10 gig E. We have and then here we have our max configuration, what it can scale to. So now instead of 8 nodes, we're 16 nodes. Our IOPS have gone up to 50,000 and so forth. So we can go ahead and we'll select this Fast Track solution. Now we have to pick the data that we've gathered from our infrastructure. Now we're not going to run the assessment, that can take days or weeks, but instead we'll pull up a report that's already been generated. We'll click next. And right here it says I brought in 164 machines, and all of them will be considered, none of them will be ignored. We'll click OK. It's telling us again the maps are the Fast Track solution that it's going to place them against. It's running the assessment. And here's our result. If we come down to results, here it is. Number of Windows servers discovered, there was 119, so on and so forth. And here is how it fits onto our fast track infrastructure. You can see under our base configuration, we have 8 hosts. And this number, the 164 virtual machines, basically fills up our base configuration. You can see our CPU utilization on host 0 through host 6 is in the 90s. And then host number 7, which is our 8th node, essentially is running with a little bit of extra capacity. And if you scroll down, of course, we can see what it looks like on our maximum configuration. And it's not showing it here in this view, but essentially there's host number 9 through 16, which are completely empty. So if you max out the configuration, you can see you have a lot of extra room for future growth. You could also, of course, go in and do customization. So if you say, of all the workloads you discovered, I want to exclude a few of them because they're unique workloads and they're not going to be put onto this infrastructure, you can do that. You can exclude them. You can save. And basically, the tool reruns. And you can see things like disk storage and IOPS just changed. So this is actually the latest version. And again, it's not only thinking about consolidation from one physical server perspective, but now with MAP 6.0, we're also looking at from a fast track perspective. And as additional fast track solutions will be available, you'll be able to plug them into the MAP tool and basically assess how your workloads will fit onto different solutions offered by our different partners. So that is our session for today. I want to thank you for your time. I hope it's been useful. I for sure enjoyed doing it. We're a little bit behind time, and I think the next guy's we might be at lunch, I'm not certain, but I think the next guy wants to come up on stage. So me, myself, as well as Scott Rosenblum is also a lead on the Fast Track team, and Alex from NetApp will be here as well. But I encourage you to go ahead, go to our website, take a look at these solutions. Like I mentioned, we have great solutions from Dell, from HP. We announced those solutions back in Berlin, and our new solution that we announced yesterday with NetApp and Cisco. Take a look at the HP solution in the aquarium as well. So thank you very much for your time. I sincerely appreciate it.